So for examples 3, 4, and 5, we are going to do integrals. And you'll see the integrals are going to have a lot of the same properties as the derivatives because, you know, they're inverses of each other, derivative and integral. So we're going to follow this formula and do the best we can with examples 3, 4, and 5. So example 3 is going to follow this exactly. A is my base, so here 2 is my base. And then I've got x as the exponent. So I just have to follow this formula, plugging in 2 every time I see an a. So the integral of 2 to the x is 1 over natural log of 2 times a to the x, which is 2 to the x, plus c. And you don't need to simplify that anymore. We can just leave it like that. You could multiply that 2x on top, but I kind of like to leave them separate. Like this is the constant, that's the coefficient, and this is the exponential function. So I do like to leave those separate. All right, example 4, you can almost apply the rule, except the rule only has a plain x. It doesn't have a negative x or this fancy negative x squared. So if you have anything other than a plain x, you have to use u substitution to get that negative x out of there and get it to be a plain x or a plain u. No numbers around it, no exponents. So my u here is going to be my exponent because that's the complicated part of this problem. If it was a plain x, it would be easy, but it's not a plain x. If you remember our shortcuts, when finding, we pick our u and then we'll need to know what dx equals because we'll need to sub that out, and dx always equals du over the derivative of u, which is negative 1. I'm going to simplify that to just be negative du. So I'm going to do my substitutions. It's 5 to the negative x is out, u is in, dx is out, negative du is in. Now I don't want that negative sitting out there, so I am going to put that negative out in front, and I'm going to just write that as a negative 1. So now this is very simple. It's 5 to the u du. I can apply the rule because it's a plain exponent, just a letter, and my letter and that letter, my d, u, and my u match. So I can apply the rule. I'm just going to write that negative 1 there. Just going to hold that, and then I'll do the rule. So the rule is 1 over natural log of the base is 5, times, copy that thing, so 5 to the u, plus c. My negative 1 and my 1 I'm going to combine, so it's just going to be negative 1 on top, ln of 5 on the bottom, it's my constant, and then 5 to the u will turn back into 5 to the negative x, plus c. All right, example 5. Similarly, it is an exponential function. It's 5 to the negative x squared, but it also has this x out in front, so it's a product, it's a quotient, or it's a product rule, which we don't have an antiderivative rule for. It's an exponential function with a complicated exponent, so this one for sure, we will have to do u substitution. And with these, u substitution is, you know, you're always just going to pick that exponent because that's going to be the complicated part. So it's an easy pick for the u. The u is going to be negative x squared. Remember my shortcut, I do need dx. dx is du over the derivative of u, which is negative 2x. Then I'll go in and do my subbing. So x times 5 to the u, because I want a negative x squared out, dx equals du over negative 2x. And it worked out great. That x and that x cancel. And that's what I wanted. I wanted my x's to cancel, and they did. I do have this leftover negative 2, and it's a divide by negative 2. So I'm going to pull that out in front of the integral so it's not bothering me while I apply my antiderivative rule. So I wanted my integral to be as simple as it can be. 5 to the u. It'll, you know, fit right into my formula that I'm going to use up there. So the coefficient just stays negative half, and then I apply the rule. 1 over ln of a is the base, my base is 5. Copy the function, 5 to the u, plus c. I am going to combine my constants, so I'll multiply those together. So on top, I'll have -1. On the bottom, I'll have 2 ln of 5. And then the whole thing is multiplied by 5 to the u. U is -x squared plus c. I'm going to put my constant in parentheses, just kind of make sure that stays together. And then that's my final answer.